Hello, everyone. My name is Muazma Zahid, and I'm a senior data engineer at Microsoft. I've been here for more than a year and a half. I have been in the tech industry for past 12 years, working primarily with data engineering and the roles around it. And I'll introduce in more detail in a bit. The reason why I'm doing this session today is that as I did an earlier one in 28 days of careers earlier this year, and I got a lot of positive feedback from the community that they are interested in this career, as a lot of the enterprises are moving towards cloud. So I thought I should do this in the Sisters group as well, so more and more people can learn from it. The agenda for today is I will go over the basics of cloud computing, data engineering, different examples, how you can use it, solution architecture, some designs, principles that I've learned over the years, and share with you the skills, courses, certifications, and conferences that you can attend to get involved in this line of career and grow from there. And as Nika mentioned that please hold your questions towards the end, but feel free to write them in the chat window and I'll get to them towards the last 15 minutes of this session. So about myself, as I said, I'm a senior data engineer here. I was born and raised in Pakistan. I'm currently located in Seattle for past 10 years, and I've been in the tech industry. I've worked at a startup company and at Nordstrom, and now I'm in Microsoft. I am a mother of 3 girls, including twins. So I do understand a lot of like the challenges that women face in the tech industry. That's why I try to contribute as much as I can. I'm very passionate about data, cloud computing, AI, and I feel fortunate enough to be working on this since the start of 2012 when it was just starting up. So I wanted to share those learnings with you. And I do a lot of these diversity and inclusion efforts as I'm a lead in a local Sisters affiliated community called Pakistani Women in Computing. I'm also leading a Python accountability study group right now with Anita B, where we have around 70 people from around the globe that are learning together. I am also part of a Women of Code Cloud Lead team. There is a conference actually next week that I will be speaking at, and there are several other programs that I'm part of. So I'm very passionate about sharing my learnings with the community and the people that are just starting off or in the mid-career, or even learning from other people's experience, what they have seen, and how can we work with each other and build those connections and grow together. So I usually start this by showing some quotes and some things that I find very insightful. So economists actually claimed a few years ago that data is the new oil. So you can imagine that it's the most valuable resource at this point. There is a lot of insights that you can get out of those databases that you have somewhere in your organization. And then you need a lot of people to actually find the right data, to extract it and to refine it, to actually distill the value out of it. I also like this quote a lot from Kate, who's the vice president of DreamWorks. She talks about data is the new oil, AI is the new electricity, and IoT is the new nervous system. And according to this survey, if you look at the numbers, so by the year 2025, we will have 150 zettabytes of data. I would just let that sink in, because that's almost 3 to 4 times of the data that we have today. So within the next 5 to 6 years, you can imagine how much of the data we would have in hands. And that actually means that we will need that many data professionals to actually make sense of that data. So that's why there's a need to actually use the data. You need the data analysts, scientists, and data engineer roles. And as more organizations are moving towards cloud computing, you need to understand the basics of that and start working in that field. This is another jobs landscape slide in 2022. You can see the top 10 emerging roles. Out of the 10, I would say 3 or 4 are actually related to data. So data analyst and scientist is the highest ranked job right now. It's well paid as well, and then AI machine learning specialist and big data specialist, and some of these special programming skills that you need. So I will be talking about that later as well, what you need to upskill yourself right now, how you can get into this field, what are the different courses you can take, and certifications you can do to actually do that. So at this point, there is a short poll. If you can just answer that, do you currently work as a data engineer, analyst, or data scientist in your current roles?
Let's wait a few more seconds for anybody who has not participated yet to have a chance. Okay, I think we can close the poll and let's see the results.
Okay, so so most of you are not in that role right now, and some of you are. So that's good. So I can give you the tips to actually get into this, because if you're attending this call, you might have some interest in this field. So that's awesome. So where do you start, right? The terminologies like container, serverless, IoT, hybrid cloud, it's very intimidating. So let's just start from the very basics. What is cloud computing? Simply put, cloud computing is a delivery of computing services that includes the servers, the storage, databases, networking, analytics, and intelligence over the internet. It offers the scalability typically that you pay only for the services you use. And it helps your business to actually look at the possibilities that you never had in your on-premise data center world. For example, if you have a website that you currently have, let's say, 100 users, right? What if you have to run a product on it and you're expecting a demand of 100,000 users to show up one day? If you are in a regular on-premise world, you might have to wait 2 to 3 months to actually get the right hardware in, to get the software, network, and everything to be set up. In the world of cloud, you can do so with a click of a few buttons. So that's the flexibility that cloud computing allows. So I have another poll at this point just to understand, do you use any cloud computing technologies right now? And which cloud computing platform do you currently use?
Just a second. Okay, here we go. Okay, a few more seconds. I'll close the poll and here are the results.
Okay. So that's great. We can do the next question.
Okay, great. And the third poll question is right here.
So if you use any of the cloud computing platform, which one do you use?
Okay, a few more seconds before we close the poll. Okay, I'm gonna close the poll. Thank you for participating, and here are the share results.
Okay, that's great. So I see one person is multi-cloud. Most of you are AWS. One person is using Azure. That's good. And then we have a Google Cloud Platform as well. So, okay, that's great. So with that, I will just share the independent survey again done by a company which is called Canalys Cloud Canals. They did this analysis as of last year, end of last year, for the market. And as you can see, Amazon AWS is the market leader right now, followed by Microsoft Azure, and then Google Cloud, Alibaba, IBM Cloud, and others. So that's the current landscape that the cloud computing services have. And you can see in the last column that the annual growth year over year, and it's exponential. So these teams are hiring like crazy. These companies are hiring crazy, and there's a lot of work that is coming in the cloud. A lot of organizations are moving towards cloud. So there is a lot of market demand as well. So you can just look at this chart and understand like how these roles are getting more relevant, and why you need to know about them if you are in an organization or an enterprise. They might be using cloud right now, they might be talking about it, but it's important to understand and get yourself familiar with that. So with that, I would start again with the very basics of cloud services, right? In the cloud services, you have different types of services, and choosing the right service for the job that you're trying to do, it's really important and makes a big impact on your application and code. The very basic one is infrastructure as a service. That you can imagine as a machine that is somewhere else. It's just a PC or a Linux server that you can use to run your application and code on. So the cloud provider is only responsible for providing you the hardware, and everything that runs on that hardware is your responsibility. An example of that infrastructure as a service would be AWS EC2 machines. Azure has a thing called VMs that you can do, and you can, with a few clicks of button, you can bring up a VM which lies in some region that you can use just by connecting through your local desktop or a Mac or whichever PC you're using. The second one, which is heavily used these days, and it's actually gaining a lot more interest from different organizations, is platform as a service. Platform as a service is when everything related to the platform is the responsibility of the cloud service provider. In this case, AWS or GCP or Azure. And they are responsible for any upgrades, downgrades, any patches they have to do, anything like that. You're not responsible for any of those things. They maintain all the hardware and the infrastructure related to that, and they provide you a working platform of something that you can run your code on. So in that case, you are totally responsible for the application and code, but then anything related to the platform, any updates, installs, anything like that is not your responsibility. An example of that would be a relational database system like Amazon RDS or MySQL. So the software is they're already there, and the patches are already there. You just go and you get a login string to actually log into that database. So that is an example in AWS that you can use right now. In Azure, a similar example is their Hadoop offering called HT Insight, which is managed by with Microsoft Azure, and you can just log in and run your Hadoop jobs on that. Anything related to the platform is actually Microsoft's Azure responsibility. The third one is simple software as a service. A good example of that would be Gmail. So the entire software, the experience of that software, everything that runs in that software is the responsibility of the service provider. And you just go to your web browser or your device or mobile phone and actually start using that software. So that has existed for a while now, and now these software companies are moving their software and application and code to cloud. So now they're maintaining all of that in the cloud, and they give you just an entry point to actually use that software. So it's also one type of service. The fourth one, which is a very recent one in terms of all these ones, and it's been gaining a lot of, again, interest and market I would say, market share is the serverless computing. So you must have heard that word. If not, it's basically a function as a service. So in this case, what the difference is, like everything, including the code, anything outside of the code, everything else is actually responsibility of the service provider. So you just bring your piece of code. You don't even need to know where it is running, what platform it is running on, what number of machines or servers it's using in the behind. All you know is tell a particular window that this is the function or this is the piece of code I want to run, and I want to run it for this many times or this scale. And everything on the backend is actually responsibility of the service provider. An example of that is Lambda. Lambda functions in AWS. Google Cloud Function is a similar one, and Azure has a thing called functions as well. So you can take any language, for example, Python or Java or anything like that, and you can go and write your code in there, and then just tell them that I want to run this at this scale, and it just takes it builds a platform on its own when you run it, and then first time it takes a little bit longer, but then every time you get a consistent timing to actually rerun those pieces of code. So that's latest in the field, and a lot of people are redoing their architecture actually to use serverless computing, where you don't have to manage any servers. There's another one called container as a service, which I didn't include in this slide, but that's a talk in itself, maybe for a later time. That's also gaining a lot of interest these days, which is about Kubernetes and other technologies like that, Docker and things like that, which actually run the things in a container, and then you can scale it at a large number. Another slide to actually show you the same thing is your on-premise world. If you look at the left-hand side, is the word is your data center, or is the platform that your company has all your data on. That in that world, everything is managed by your IT team. As you move from the infrastructure as a service to container to platform to functions as a service, you can see that there's less and less that you have to maintain, and everything is managed by the platform provider. So from left to right, you can see you start losing the control, but you actually gain the flexibility, because at that case, you don't need to worry about the servers and machines and have the DBAs run those patches for you. They are all maintained by the cloud service provider, and you bring your code and actually run those things at the scale that you want. So how do you start building data pipelines in cloud? I thought I would put architecture out there so you can start understanding the basics of data engineering in cloud. This is a Lambda architecture. It's not just limited to cloud. You can do this in the on-premise world as well, but this is fairly heavily used in a lot of customers that I work with, where they have basically two pipelines of data. So every organization has a bunch of data lying around, right? It might be an Excel sheet sitting on somebody's PC. It could be a big database of all your customer data. It could be your sales data. It could be anything that your business is actually doing. So from that, there are two types of pipelines that I see people doing, and they're not mutually exclusive. You can have both, or you can have one of them, or you can choose to have mix and match of both depending on your problem that you're trying to solve with the data, or the solution that you want to get out of the data. So the top layer is actually the speed layer, which is more near real time. So imagine that if you are running a bank that has fraud detection. So sometimes you must have seen that if you have a credit card, if there is an anomaly, there's some activity that happens out of the norm, you usually get an SMS right away saying that, did you just use your card at this location, or was it you that this happened? Or sometimes it gets declined automatically. So how do they actually detect this in the real time, right? So they're using these real-time processing systems where they're sending data from this the location where the activity happened to some central place. It could be in the cloud or in their on-premise world, and detecting based on some machine learning or AI algorithm some kind of anomaly and figuring out what's happening. So that's the top layer where everything happens within like seconds, sometimes like less than a minute, which is your speed layer. The traditional BI world, if you're in that roles in any of the current organizations that you're working on, is more of this cold path, which is the batch layer, where once in a day or once every 6 hours or something, some frequency that you collect all the data from these different sources and you land it somewhere in some kind of storage, and then run your data warehouse systems on it. So big systems like SQL Server, or you could have a Teradata, or you could have an Oracle system that actually taking that data, combining them, and then making sense, and sometimes some type of a front end with a report in front of it. So that is a very high level introduction to what these different types of paths that you have, and depending on what your interest is, you can start looking at the technologies that are used in these layers and could be an expert in those layers. And I'll be talking about those skills later as well, that you can get up to speed if you are interested in one or the other. So a typical cloud data pipeline based on the previous architecture, as I talked to you about, is that you take the data sources. You first have to identify those data sources, where they are, what type of sources they are, what type of data they have, what is the format, what's the frequency of the data. You need to understand your entire data landscape. If you have some kind of data governance already in your organization, they might have a data catalog which describes all this, that what data is where and who has that. Or you might be going in and have to do that analysis by yourself. Based on that, as I said, there are two paths. So the cold path is usually the cheaper path, where you can store a bunch of data in a central place. In the cloud world, I will take AWS example, where you have S3, which is their storage component, where you can store petabytes of data with a very minimal cost, and you can store in almost any format that's possible. You can store binaries, you can store Excel sheets, you can store Parquet, any format that you want to in that storage. From there, you usually have a batch processing layer which comes in. You have an ETL tool running that actually takes the data based on a certain time or source system that you want to combine the data together, run the tables, run the procedures, stored procedures, or whatever ETL that you want to do on that, and then land that to an analytical data store, which is the traditional data warehouse systems that we have seen for a long time in the BI space. The real-time data path is relatively new, but it has been around for a while as well, where you get technologies like Apache Kafka, Event Hub. Amazon has a thing called Kinesis. Azure has event hubs that you can land data on. They can land in real time as soon as a data point is available or data is generated. You can land that to that streaming pipeline, and then you can run real-time stream processing on it. So for example, if you are looking for a particular event, like for example, anomaly in your data that a person is located in Seattle, but you see that their credit card is used in somewhere in Europe, then you can actually create alert to your system, writing a function like you can do that using lambdas that I talked about, or you can use that in Azure using Azure functions, and send an alert to your downstream system or whatever way, like SMS, or you want to communicate. You can tell them in real time that there is some anomaly that's happening. So that's that path, which is right here, which is a real-time message ingestion and the stream processing one. Usually in that you will see people running machine learning and AI on top of it to understand this type. Like I just gave you an example of anomaly. If you are a retail system, you might be doing that for different recommendations that you do. So based on different clicks that you do on the website, they might be recommending you, and you might be like, why, how do they even know like you like this particular item or set of items, right? So that's based on your past and present data. So the past data might come from that batch processing layer, and your real-time data when you're clicking on a particular product might come from this layer. And finally, last but not least, there are reports that you have to build on top of that. Every CEO, every leadership team actually loves reports. So they want to see how their business has been doing. So you can run that on top of your analytical data store, and sometimes directly from these systems, you can build these real-time reports also. Softwares like Tableau, which is a which is not affiliated with any of these cloud computing. You can use that, or you can use specific ones, like you can use Power BI in Azure, you can use QuickSight in AWS, and there are a bunch of others that you can use to actually build these reports. And in this landscape of data pipelines, there's usually an orchestration layer which actually does the data run from point A to point B, which is your ETL tools. There's Informatica, there's Talent, there is a very specific one. For example, Azure has a thing called Data Factory. AWS has a Glue, which does the same thing. So you can use a very specific cloud provider, or you can use a third party which is not affiliated with that cloud provider, but they have connectors to all of these things that I talked about. So just summarizing all the steps that you have to do, you have to understand how do you get an extract, how do you get this data from one point to another. You need to understand the data types, the frequency, and all the things. Then you have to understand how do you ingest the data. You have to build a new code base to actually get the data into the system, or is it an existing connector that you can use? And data ingestion can vary from the cloud provider to another cloud provider. Some connectors might be already available. Some you might have to get from the open source world. That is something you need to understand. Then how do you store this data? As I talked about different storage options, you can store it as the data arrives as it is. You can do some manipulation of the data and then store it. That's completely up to you. That is based on you and your architecture design. And then how do you prep the data? So how do you clean the data? How do you make sure that this data is coming from the right source and it has the right information? So you need to understand the data quality issues. How do you do the basic checks? For example, if you are anticipating an address in a field, and what if they just put a phone number over there? So how do you clean the data set for anything downstream to actually consume that data? Then you have to do traditional data modeling on it. In some cases, you do like star schema to actually help that to for the downstream visualization. And in the new data science world, how do you run your models on it, right? How do you make the data, how do you extract features out of the data? How do you run different data models on it, different predictive models or any forecasting model or anything like that? And then finally, from the results that you've got, how do you visualize it? So these are all the important steps, and there is different technology options for each one. And for a particular use case, you can take the data from one point to another point and make sense of it. Again, in the cloud world, there are some important concepts that you need to understand. And as you start using this more and more, you would realize that how quickly you can cost your company a lot of dollars if you don't understand this. So it's important to do that. So the first one is compute. So compute is anything that has CPU cycles in it, that's running something. So if you have a VM in Azure which is running a piece of code on it, then the VM itself is considered the compute. If you have a Hadoop type system which is doing a lot of data processing, then it's in a clustered environment and it's an MPP, multiple processing units in it, and each unit costs you money. So you need to understand that concept of how many nodes you need, how many compute you need, what type of compute you need. In the cloud world, there are different types of compute options as well. They could be memory optimized, they could be CPU optimized, they could be IO optimized, or they could be general purpose. And for some of these new machine learning type things, they have GPU type compute as well, which is of course way more expensive, and it's very hard, big, beefy machines that you can use. So understanding of compute is important, and then understanding of the cost related to that is also very important. So second is storage. So again, different storage options are there. What types of disks you want to use? Again, in the disk industry also, there are different types of disks. There are standard disks, there are premium disks, there are ultra SSDs, there are like different types of things, and of course the cost also varies by each type. When you start your cloud journey and you go through these portals and click on different things, they give you all the options, and they also give you the price associated with that. Sometimes when you're starting off, there is some basic free tier that you can use, and that free tier usually comes with some basic compute, storage, network, and security options. But as you grow and you build more applications in cloud, you will learn that there are so many options, and it's the world of cloud is very haunting, because like every other day there is a new service, and every other day they're adding more things, and they're in this market and competing with each other. So there's a lot more to learn and keep your skills up to date in this field. I want to really emphasize on this last two, the network and security. You can easily cost your company a lot of money if you don't understand the basics of the network and security in cloud. Because if you don't understand the authorization and the authentication models that you have in cloud, and they vary from every cloud provider to other cloud provider. So it's important to understand those concepts. What is a role? What is an IAM? How do you set up different policies? Who can access what? And how do you ensure that whatever you're running in cloud is protected in the network that you want to run in? Unless you're running an open source data set and you don't worry about that, that's fine also. But if you are working with enterprises and they have sensitive data or PII data, it's very, very important to understand the concepts. How do you use cloud, but in a protected way, in a way that you have a secure network and gateways are set in the right way, and the roles and authorization and authentication is pretty clear. So all these concepts, they're important, and as you learn more and more, you will get comfortable, and don't get just spooked by all the terminologies that I'm using here. Once you start with a project and you start learning these concepts, they get easier and easier as you use them. So some of the example applications I wanted to give you, for example, a connected car, right? These days you have an app in your phone which you can use to actually unlock your car, or you can use to update the software that's running on the car. So how does that all think this whole click and then works with a car which is not connected to anything except for a Wi-Fi or something like that, right? So usually these connected car platforms have the data either connected to their on-premise system or to a cloud system where they update the data all the time. And as you are running that, if you've used Tesla, you know that everything in that is actually, you can connect through your phone on that. So all of that is actually connected, and they have the right application and software running in these servers, which are processing your data in real time. So that's one example. Online shopping, I love online shopping. I believe most of you would like as well, is that you go and click on different things, and they start showing you recommendations. They start showing you the options and the things that people have bought once they bought this thing. So all of that is based on a set of data engineering pipelines or data science pipelines that somebody has built, and they've collected the data about either you as the customer, or they've collected data of other customers who have done that kind of shopping. Voice is the new norm in a lot of households that I know around here in Seattle area. I'm sure in other places as well, where you use Amazon Alexa and talk to it and say, Alexa, what's the weather today? So that voice command is actually converted into a data engineering pipeline on the behind, and it's actually taking that voice command, getting the data about the answer, running a model on that, and then returning you results in the real time, right? So that's all built by Amazon, or Google Home does the same thing. It's a pipeline behind it. Some of the advanced applications are disease detection, like cancer detection, autism. There are other AI specific fields. A lot of people are doing a lot of research right now, and I've seen a lot of positive results that was not possible a few years ago with the limited set of data centers these big companies had. Now with the cloud offerings, you can go to any region and have these set of machines running your code on it, and can do that work much faster and in a very big scale that you could do in on-premise world. And as I already talked a lot about anomaly detection, that's a streaming application example that we all have seen, or most of you have seen that. And I don't want to forget like the traditional BI reporting, because a lot of these companies are still doing that, where they want to know their sales year over year, month over month kind of analysis, and run their reports on them. So these are all the examples in real life that I hope that most of you have seen around you that have data pipelines running behind them, and somebody has built those pipelines, and they might have used some cloud computing technologies for those, or they might be thinking about moving to cloud, but they are using those technologies that I talked about earlier. Some of the top considerations in this set of pipelines is understanding of the DevOps world, the ops world, the CI/CD pipelines, the blue-green deployments, the automation, because you don't want to manually sit and run and upload every piece of code that you do. You need to have automation in place that if there is a new update, how do you update all the downstreams or upstreams that get affected by that? So there are many tools in the open source world that provide that. For example, Jenkins does that. AWS has CloudFormation, where you can build the dependencies, the scripts, and everything that you can run. Azure has ARM templates that run the same thing. So understanding of those concepts is important. If you're building a code, how do you automate it? How do you run it at a scale? Security networking, again, I cannot emphasize enough on that. Understanding of all the different roles that different people play. It might not be your role, but as a data engineer or data scientist, you still need to secure your code. You don't want to put your passwords in your GitHub. Those are some basic things, but yeah, understanding of these concepts is important. High availability and disaster recovery. So I work with customers a lot where they initially don't think about this, and then after a while, when the server is down in cloud, you can imagine, because you're running it in some data center somewhere, right? Just hypothetically speaking, what if a tornado comes and just destroys the data center completely? What will happen, right? All your data and application is in that cloud. So how do you recover from that? How do you recover your user base and your website and everything else that you were running in a situation like that? So if you have a critical application that depends that your data and customers depend on, then you need to think about these concepts. How do you make it there are different principles you can use. You can use active, passive kind of scenarios, where if one is down, you can bring up the same infrastructure in another region in a few minutes. So all of that options are there, and there's a lot of guides available online that you can read through it. If you're building a platform, how do you make it highly available, right? And how do you put in the code and to actually recover from the scenarios that I just described. The scale and cost, they're like sisters. So basically, if you want to run at a bigger scale, of course, it comes at a cost. So you need to understand the speeds and feeds of your data. What is your average load? How the load varies from time to time, and how you can adapt your application to that load and run the code. Most of these cloud providers come with auto scaling options, so you can set that rules that when to auto scale. If you see certain set of users coming up in a particular region, you can scale in a particular region also. So all of that you can do by setting up the right things up front. So understanding that and having the data in your back of your head is important, and of course the cost with it, because as I said, in few clicks you can cost your company, or if you're doing your own project, you can cost a lot of money. And of course, once you are in cloud, how do you monitor your systems? How do you monitor if there's any issue, if there's anything happening? So that's there are a lot of tools available in these cloud providers, and you can set up the rules over there and go from there. Some of the tools, technologies, and skills. This is just a very starting basic list of the things that I've seen recently getting a lot of interest in the industry. This is by no means a total list, but Python is gaining a lot of interest in big data world. It's also in data science also, so you can Python or R. SQL is not going away anywhere anytime soon, so it's important to actually have those concept of data analysis. Any type of ETL tools, big data, Hadoop ecosystem, NoSQL like Cosmos DB or DynamoDB. They are all here they've been here for a while and they are not going away. Streaming applications I was talking about, so Apache Kafka is one that's an open source platform that you can use for stream processing. Spark is gaining a lot of interest. A lot of big companies, I know they're using it on heavily. So if you can learn that, that would be awesome. And then finally about data governance, so the data catalogs of the world and understanding of the data lineage and how data goes from one point to another is the set of tools and technologies that would be relevant in this field. Some of the online courses, there are a bunch of courses if you just search cloud engineering or cloud computing or big data AI. So you can find a bunch of this. This is a list of some very good ones that I've done or gone through. There's a bunch on Coursera, there's LinkedIn Learning, Microsoft Azure has specific ones, and the Cloud Guru has a lot of AWS courses that you can do. Some of these certifications that are also relevant to this field, each cloud provider has their own certifications that you can go through. They also have exercises that you can do related to that and courses related to that. So AWS has one, Microsoft has one, Google has one. You can do that. That would be one path to actually add to your resume and go from there. I've seen a lot of people getting into the field just by doing these certifications. Some of the related conferences, AWS has a yearly conference in November, which is the reInvent the Biggest conference, where they talk about all the new things. They a bunch of learning sessions over there. So if you get a chance, you can do that. Microsoft has built an Ignite conferences twice a year that you can attend. Google Cloud Next is a similar one, which talks about the Google Cloud platform and all the offerings. And some of the other ones that I find very relevant and are interesting data conferences are Strata, DataWorks, Sparkly AI Summit. And there's a conference this weekend, Cloud Summit, the Women Who Code Cloud Summit in San Francisco, that you can attend to learn more about what's happening in the cloud field. Some of the other ways to learn is like how I like to keep myself up to scale, up to date, is by taking these open source data sets and doing some data analysis by myself. So Kaggle has a lot of data sets that you can use. They have real business problems where different organizations actually post their business problems there that you can compete. There's a competition, there's a set of competitions that happen. You can actually earn big money, big checks also over there if you want to, but that's a starting point that you can go and get some of these open data sets to do some analysis on. They have Jupyter notebooks that primarily uses Python to actually run different types of code that you want to. There is a Google data search option. That's the biggest open data set that you can find. You can search for any data set over there and it will find it for you if it's available. So that's another way to actually get some of these data sources and start building your GitHub repository of writing code on that and showing projects. There's this one analytics Vidya. They have competitions also that you can compete in. I know they have a big conference coming up soon as well. That's another way to learn. So I just wanted to quickly show a couple of projects that I did recently using the cloud. So this is one for the Women Who Code Connect conference earlier this year. This is the Twitter user location data analysis. So basically I collected every data point in real time about a hashtag of that conference. And I was just doing analysis of where most of the people are that have come to that conference. And you can see a lot of them from US, but then they are from all over the world as well. So you can quickly build these, and I literally built this dashboard in like I would say half an hour. I have a link of that for the GitHub that you can go and check on that how do you build something like this quickly. So just take this an example, and you can see how you can build some of the interesting data analysis and build your data profiling. This is another one interesting one. I just did it for fun. This is the Game of Thrones data analysis of understanding if a particular writer has an impact on the viewers or ratings. As you can see, the last season was pretty bad as compared to the rest of the seasons. And that was the lowest rating they ever got with that set of writers, but consistently it was good enough. So there is a link over there that you can go and see, and I have a GitHub with with the code that actually created this visualization. So you can actually take any data set, and this is an open source data set that I got from IMDb and a bunch of other sources, and did this analysis just for fun. So we'll leave with this slide. This is, to me, I feel like this is the role of a data analyst or engineer or scientist in a company, where you have this just data points in your company. You actually connect the dots, connect from point A to point B to actually get the insight out of that data and finally make an impact in your company. So if you look at a problem from that perspective, how do you connect the dots? How do you make sense of that? That's how you can add value to your current role or to the future role. And you can start doing that today by taking any of these open source data sets and start analyzing it and making some sense out of it. And that is pretty much the summary of the talk today. And with that, we have 11 minutes. I have put my LinkedIn here. Feel free to add me to your LinkedIn, ask me any questions. There's my Twitter also. Thank you so much for attending this call today, and happy to answer any questions at this point.
Thank you very much for the presentation. If you have any questions, please put them down in chat or use the Q&A button at the bottom of your screen. Okay, there's a first question. Muazma, can you access the Q&A on your side?
Yeah, I can. So the first one is about the online class. So these are all the online resources or the courses that I found relevant that you can see. And then there's a question about when and where the recording of the session will be released. So Nika, can you answer that one? So for the recording, I think after this session, it should be released soon. And probably I think it should come in an email with a link. But I'll let Lenka answer that.
Yes, you're right. So we will, as soon as we are able to, we will publish this recording on the anitab.org YouTube channel. And we will let everyone know.
Okay, there's some questions on the chat. There was no second question given. I'm not sure what that means. But then there's a question about, does PaaS include infrastructure too while maintaining patches, etc.? Does PaaS include infrastructure? Okay, so the PaaS services, that's a good question. So PaaS services actually means that you're not responsible for the infrastructure, but you actually get the login information to get into the software, that platform. So as I mentioned, like relational databases is a good example of a PaaS service where all the patching related to the software or the database is actually managed by the cloud service provider. But from end user perspective, you don't need to know like what's happening. You get an access like a login information to that platform. You don't even know where it is running, what is the where the actual machines are, where it's running. You actually get access to the software, but once you get access to the software, in this case like RDS, anything you want to do on that platform would be kind of your responsibility. So for example, if you want to create databases over there or create tables over there, that is something you or your DBA will be doing. So you get the platform and that's provided to you as a service, but what you do with that platform is your responsibility. So did I answer your question, Sally?
Okay, so far no questions. We can wait. We still have some time. We can wait a minute or two if there's more questions, if somebody's still thinking of asking.
Okay, so your question, you follow up, is the provisioning of VMs included in the PaaS? No. So the provisioning of VMs is actually in the PaaS service is a responsibility of the cloud provider. In the IaaS world, the infrastructure as a service, the provisioning of VM is your responsibility. In the PaaS, it's not your responsibility. What VMs it runs on, or a set of VMs it runs on is the cloud service provider. So as I said in the example of a RDS or a HD Insight type service, which is a PaaS service, you go to the portal and you click on what type of things you need, like what type of cluster you need, how many nodes you need, what type of nodes you need, and you click create. Once you click create, it goes and then creates the infrastructure for you. You are not responsible for writing any code to actually create the infrastructure for you. And in some cases, some of these PaaS services, you don't even know where it is. Basically, what particular, you will not get, let's say, a machine ID that this is running on, but what you'll get is a connection string to the service. In this case, a database, you will get a admin user password, whatever you created while you went through the portal and you got to it. Awesome.
Great. And there's one question. Are you attending GHC this year?
Yes, I am. I am super excited about it. I will be there. You can connect with me on the LinkedIn, and if you want to meet with me, more than happy to meet with you, talk about more things.